Today we will correct our Christmas worksheet. Let's start with exercise number 1. Complete the following table showing your calculation. Let's start with the first element here. You have the symbol of the element, it's capital letter O. So it's oxygen. It's given for you that the atomic number for this element it's equal to 8. So we can say that atomic number, which is capital letter Z, it's equal to the number of protons, it's equal to 8. So we write here 8. Now, since atom is electrically neutral, number of protons equal to the number of electrons, it's equal to 8. So again, we will write here 8 adjacent to the number of electrons. Now, to calculate the number of neutrons, which is missing here, we will use the following relation, A equals Z plus N. So the number of neutrons, it's equal to 16 minus 8, it's equal to 8 neutrons. Now, moving for the second element, here you have the name of this element, it's potassium. So the symbol of this element is capital letter K. Now, we have that the number of electrons it's equal to 19. So we can say that since atom is electrically neutral, number of protons it's equal to the number of electrons, it's equal to 19. So we put here 19 adjacent to the number of protons. Now, atomic number, it's equal to the number of protons, so also it's equal to 19. Now, to calculate the mass number, again, we will use this formula, A equals Z plus N. So, A equal 19, which is the atomic number, plus 20, which is the number of neutrons it's given for you. So, the mass number here for potassium, it's equal to 39. Now, for the atomic symbol, it will be written in the following way. We have the chemical symbol of the element in the middle. We will write the mass number to the left as an upper subscript, and we will write the atomic number also to the left as a lower subscript. So this is called the atomic symbol for the element. Now moving for magnesium, which is Mg, so it's called magnesium. Atomic number, it's equal to 12. So we can deduce that atomic number, it's equal to the number of protons. Also, it's equal to 12. So we will write here 12. Also, it's equal to the electrons, since atom is electrically neutral. Now, to calculate the mass number, again, it's equal to 24, using the same formula, A equals Z plus N. Now, for the atomic symbol, it's Mg, the symbol for magnesium, mass number 24, written above, and you have the atomic number, which is equal to 12. Now, for the last element, nitrogen, so the symbol of this element is capital letter N. Number of protons is equal to 7, so it's equal to the number of electrons, and it's equal to the atomic number also, it's equal to 7. Number of neutrons will be equal to A minus the atomic number, it's equal to 7 also. Now for the atomic symbol, it will be written in the following way. We have capital letter N in the middle, 14, 7. Now question number 2. Determine the atomic number of aluminium atom, knowing that it has a mass number equal to 27 and 14 neutrons. So it's given for you that the mass number is equal 27, capital letter N, number of neutrons equal to 14, and you need to calculate the atomic number. So we will use the following relation, A equals Z plus N. So Z equal A minus N, it's equal to 27 minus 14, so it's equal to 13. So we can say that the atomic number of aluminium atom is equal to 13. Now, question 2.2, determine the atomic number now of a bromine atom, which has mass number, capital letter A equal to Z plus 10, knowing that the number of nucleons is equal to 80. Now, For the number of nucleons, it represents the mass number, which is the total number of protons and neutrons. So using the given relation here, we can calculate the atomic number. You have just to substitute the mass number here, and then we will deduce that the atomic number of bromine is equal to 35. Now moving to question number 3, calcium atom with the symbol Ca contains 20 electrons and a mass number equal to 40. So we have capital letter A, it's the mass number, and you have the number of electrons. 3.1, determine the composition of calcium atom. The composition means that you need to calculate the number of electrons, protons, and neutrons. Now, number of electrons, it's given for you, it's equal to 20. To calculate the number of protons, you just have to say that since atom is electrically neutral, number of electrons equal number of protons, it's equal to 20. Now, for the number of neutrons, we will use the only relation, N equal A minus Z. So it's equal to 40 minus 20, it's equal to 20 neutrons. So the composition of calcium atom, it will be 20 for the number of electrons, it contains 20 protons, and it contains 20 also neutrons in this case. Now 3.2, write the atomic symbol of calcium atom. So the atomic symbol for calcium, it will be Ca. You have 40 as an upper subscript, it's the mass number, and we have a 20 as a lower subscript, it's the atomic number. Now, moving to exercise number 2. Sulfur is a tasteless, odorless, brittle, and dull yellow solid with density 3.1 gram per centimeter cube and melting point 113 degrees Celsius. It is found in dairy products and eggs, and it is considered as an essentially dairy ingredient. When sulfur is hammered, they shatter into small pieces. Hydrogen sulfide is obtained when sulfur combines to hydrogen. It smells like rotten eggs and it is quite poisonous. Sulfur burns with oxygen of air with a pale blue flame producing sulfur dioxide. When oxidized and combined with atmospheric moisture, it is considered as one of the principal ingredients of acid rain. Question number 1. Specify whether sulfur is a metal or a non-metal. Sulfur is a non-metal since according to the text it is dull and brittle. It means that it can be broken down easily into small pieces. Question number 2. Complete the following table. For non-metals, it's given for you that most non-metals are gases, others are solids, while bromine is liquid at room temperature. For metals, we can say that all metals except mercury are solids at room temperature. Metals are shiny and have luster, while non-metals look dull and have no luster. Non-metals also are poor conductors of heat and electricity, while metals are good conductors of heat and electricity. Non-metals are not malleable, they cannot be hammered into thin sheets, while metals are malleable, they can be hammered into thin sheets. Metals are ductile, they can be drawn into thin wires, while in return, non-metals are not ductile, they cannot be drawn into thin wires. Metals have high boiling and melting point, while non-metals have low boiling and melting point. Non-metals also, and especially solid non-metals, they are brittle, they are broken easily, while most metals are hard, they are not broken easily. Question number 3. Pick out from the text 2 intensive properties for sulfur. Justify. The 2 intensive properties, they are density and the melting point. Intensive properties does not depend on the amount of matter present. Number 4. pick out from the text the names of two compounds. They are hydrogen sulfide and sulfur dioxide. 4.2, also pick out from the text the names of the three elements, indicating the chemical symbol for each one. They are sulfur, capital letter S, hydrogen with capital letter H, and oxygen with capital letter O. Now moving to exercise number 3. Sugar can be decomposed by heating into carbon and water made up of the elements hydrogen and oxygen. As shown in the figure below, a change takes place. Identify the nature of sugar elements or compounds. Sugar is a compound because it can be broken down by heating into two simpler substances, which is given for you. They are carbon and water. Number 2. Specify whether the decomposition of sugar is a chemical or a physical change. The decomposition of sugar is a chemical change because the identity of sugar changes upon heating. Number 3. Name the substances constituting water. The substances constituting water are oxygen and hydrogen. Number 4. Indicate the nature of the substances constituting water as metals or nonmetals. The substances constituting water are hydrogen and oxygen, and both are nonmetals. Now exercise number 4. Below is a list of substances. We have hydrogen, phosphorus, iron, gold, mercuric oxide, silicon, bromine, helium, sulfur, mercury, muddy water, and iodine. We want to classify the above substances into metallic or non-metallic elements. 3 substances have no place in this classification. Part A. Identify the intruders. Here the intruders are mercuric oxide, since it's a compound, silicon, since it's a metalloid, while muddy water, it's a mixture. So this is because mercuric oxide, it's a compound, it's not a metal or a non-metal. Silicon is a semi-metal, or we call them metalloids. And muddy water is a mixture of water and mud. Part B. Classify the remaining substances into metallic or non-metallic elements, or metals or non-metals. For the metallic elements, the metals are iron, gold, and mercury. Non-metallic elements, they are hydrogen, phosphorus, bromine, helium, sulfur, and iodine. Now, question number 2. Complete the table below to differentiate between metallic and non-metallic elements. Now, for the metallic elements, the physical state at room temperature, it's solid except mercury. For the non-metallic elements, we can say that most are gases, others are solid. We have a special case. Bromine is liquid at room temperature. Now for the melting point, for metals, they have high melting point. For non-metals, they have low melting point. For the electric conductivity, metals, they are good conductors of electricity. Non-metals, they are poor conductors. Now for the ductility, metals are ductile, non-metals are not ductile. Now for the luster, metals are shiny, while non-metals are dull. Please be safe and keep up the good work. Thanks for watching.